Hello and welcome to my channel. Today I'm going to show you very unusual reducer. Ta-da! This is a cable-driven reducer. I haven't seen the reducer like this before, so I think it's gonna be very interesting for you. I designed this reducer around 1 year ago when I was looking in details to the ambidex robot arm which called LIMS2. I made a video about this robot arm last time. LIMS2 stands for the low inertia manipulator with a high stiffness and strength. And I really liked the reducer, the cable-driven reducer which they used in the elbow. Basically in the wrist they also use some kind of the same reducer. I was really impressed by this reducer and I wanted to design something similar but different. So I came up with this idea. I don't think that I'm the first who invented this reducer because the construction is quite simple, so I'm pretty sure it existed before. So if you know the name of this reducer or if you have any information about this kind of reducer, please leave the comment. In order to understand how this reducer works, you need to understand how the polish works. And for this there is a really good video from Smarter Everyday. The video is called Why Snatch Blocks Are Awesome. But basically it's like this. For example, you have a weight and you need to lift it. If you take just one pulley, fix it to the ceiling and pull this rope, like this you don't have any mechanical advantage. But now if you add some more pulleys, so in this situation with 2 pulleys you're gonna have mechanical advantage of 2. And of course you can increase it. And for example in this situation with already 1, 2, 3, 4 pulleys, you're gonna have the mechanical advantage of 4. And so this is a basic idea which I tried to use in this reducer. So let's look into the mechanical design. In order to better explain you how this reducer works, I prepared some CAD drawings. So I have several CAD files here, and so let's start with the simplest one. So this is kind of the simplest design. So this is the output arm, this is the input arm, there is only one big pulley, there is this driver pulley. So the motor should be connected to this driver pulley. And this big pulley, it has 2 V-slots. This is not important, this is just for the construction. So one wire goes through the one slot and another wire goes through the another slot. And there is this small pulley and similar small pulley here. This is just to redirect the wires. Let's look at the path of each wire. So the wire number 1 goes like this, and you see that it goes through one side of the pulley. So when this wires is gonna be rolled on top of this driver pulley, it's gonna pull this arm into this direction. The second wire looks like this and it goes through other side of the pulley. So when the other wire is rolls on top of this driver pulley, these wires rolls from this driver pulley, and so like this it allows this arm to go into this direction. When the driver pulley rotates to the opposite direction, this arm moves to the opposite direction. So this is a very simple design. There is no mechanical advantage here, so the mechanical advantage is just 1. But now if we add some more pulleys, we can do something like this. So here again the output arm, the input arm, driver pulleys. So the motor is connected here and there is these 2 big pulleys. So let's look at wire number 1, and this wire goes like this. It always goes through the same side of big pulleys, and it's basically the same block and tackle system but just rolled on these big pulleys. So you see this is the classical block and tackle system, and the wire number 2 looks like this. So it's actually the second block and tackle system which rolls on these big pulleys from the other side. So here you see that this system is already gonna have the mechanical advantage of 2. So it's basically like 2 block and tackle system rolled on these big pulleys. Like 1, 2. Now let's see what we can do with the 3 big pulleys. In the case of the 3 big pulleys, the wires goes like this. So again this wire number 1 goes through the same side of the big pulleys, and again you see that this is block and tackle system with the more pulleys. And this block and tackle system has the mechanical advantage of how many? Of 3. And the wire number 2 is another block and tackle system rolled on these big pulleys. And now let's see what we can do with the 4 big pulleys. and this is 4. Again, this is a driver poly, the input arm, the output arm, and let's look at wires. So this wire number 1 goes here, and on driver poly. You see that wire goes again through the same side of the big polys. You see again that there is this block and tackle system. This block and tackle system has the mechanical advantage of 4, and the same block and tackle system is made with the wire number 2, which you can see here. So the wire goes here, through this poly, through this one, and it goes to the driver poly. I used this system with the 4 polys, so with the mechanical advantage of 4, and I made this design. So here I don't draw any wires, but I draw all the polys. There is polys here, here on the output arm, and there is poly here and here on the input arm. And so here I have the mechanical advantage of block and tackle system here. And also I have some reduction because the difference of the big poly diameter and small poly diameter. So the driver poly is this one, and it has way smaller diameter than these big polys. Actually, it has 5 times smaller diameter. So I have the mechanical advantage of 4 and the reduction of 5 between big poly and small poly. And so in total, this system gives me the mechanical advantage of 20. Let's look at actual design. So what we can see here, this is the output arm, this is yellow input arm, this is the driver poly. So actually to move this output arm, I need to rotate this driver poly like this. The cables, they are fixed here, and also they are fixed inside the poly. It's over here, it's difficult to see, but it's over here. And what is interesting is that this system has a reduction ratio of 20, but it's super easily backdrivable. And I can backdrive it quite fast, and the belt still unrolls really perfectly, like this. So let's look at the cable on top. It goes here, on this big poly. Afterwards, it goes on this poly, goes around on the second big poly, here, around on this big poly, comes back here, around this one, goes back here and goes to the driver poly. Another cable, it goes from the driver poly inside this arm over there, and it comes out through this poly here. It goes around this small poly, on this one, around here, on this big poly, around here, and it goes here inside of this yellow part, and it's fixed here. So actually on this side you see the entire block and tackle system, and you see how it rolls on top of the big polys. Let's look again how it works. So when I rotate this pulley, it goes like this. From this side. It's quite surprising, but cable always rolls perfectly, you see? Even if rotate it super quickly. The obvious disadvantage that this reducer is quite complicated, and it doesn't rotate more than this. So basically this is something a little bit more than 135 degrees, which is okay for elbow, because human elbow also rotates around 135 degrees. The great advantage of this reducer is that it has zero backlash, and this is because we used wires. So this is another example of the zero backlash affordable reducer. So today we looked at this unusual reducer. So this reducer is cable driven, and basically it's based on the block and tackle system, actually on two block and tackle systems This system has a reduction ratio of 20 because there is a mechanical advantage of 4 at the pulleys, and there is also the diameter difference between the big pulley and the small driver pulley of 5. So 4 by 5 is 20. It works perfectly well. I have not seen this kind of system before, so if you know the name of this reducer, please leave it in the comment. So I'm not planning to use this reducer in the robot arm, but I think it's possible to make a robot arm with this reducer. As usual, don't forget to subscribe to my channel. Apparently, according to the statistics, 70% of my viewers, they are not subscribed to my channel. Because people, they judge channel by the number of subscribers. So I need a lot of subscribers. And this also gonna motivate me. Also, you can support this video by putting the like, by putting one or several comments. And of course, you can support my channel through the PayPal or Patreon. All the links in the description to this video. And by the way, this is the name of the people who support me on Patreon, and thanks to them, I'm able to continue doing this kind of projects. I'm able to continue with an affordable human-size robot arm. And by the way, right now I'm 3D printing the parts for this new video. Thank you a lot, you are the best. So, good luck with your projects and see you next time!